Okay, so some of these will be a little bit easier than what you saw yesterday. So the first problem is y equals x. Your system is y equals x and y equals negative x plus 2. So these are going to be a little bit different than some of the ones we did yesterday. Here, both of these equations are already solved for a variable. They're both already solved for the variable y. So that's going to make this a lot easier. What I see in these two equations is that y is equal to x and y is equal to negative x plus 2. So what I can assume from these two equations, if y equals x and y equals negative x plus 2, then I can say that x is equal to negative x plus 2. If y is equal to one thing and y is equal to another thing, then we can just say those two items, those two things are equal to one another. So I can set these two equal to each other, and I can solve, in this case, I can solve for x. So this will be a little bit simpler than what we did yesterday. I would start off over here by adding x on both sides. Negative x plus x is 0. They cancel out, which is why I can mark it out. Here, x plus x is 2x. So 2x is equal to 2. So to solve for x, we would divide both sides by 2. So now I know that x is equal to 1. So I'm going to draw a little line here. Now that I know that x is equal to 1, I can substitute a 1 in place of x in either one of these equations, my choice. I would go for the first equation because it seems the simplest. So I'll just write down the first equation, or we'll call that equation A and B. So I know x is 1, so in place of x I'm going to write 1. So I know that y is also equal to 1. So I know my ordered pair, or the solution to this system, is the ordered pair 1, 1. Alright, then let's go to number 2. So number 2, you've got the equation y is equal to x plus 4 and y is equal to 3x. Let's go ahead and label these equations A and B, and I'll put that box around them so I know that's what I'm starting with. Okay, so the first thing you want to do when you're working with substitution is solve one of the equations for one of the variables. Well, this is also a little simpler because both equations are already solved for the variable y. So this is very similar to the first problem. I know that y is equal to x plus 4. I also know that y is equal to 3x. So if y is equal to this and this, then I can assume x plus 4 and 3x are equivalent or are equal to one another. So I can start off by setting the equation like so. If y is equal to this and y is equal to this, by the transitive property that some of you have worked on through your accelerated math, you've gotten to that point, we can say that these two are equal also. So this is an equation in one variable, which is always your goal. So solve this equation, figure out what x is. So I can subtract x on both sides. So 4 is equal to 2x. Solve for x by dividing both sides by 2. So x is 2. Now that I know x is 2, I can substitute that into either equation A or B to give me what y is. I say go for equation B, but it doesn't matter. You can go for equation A if you so choose. So I just rewrote the original equation. And instead of x, this time I'm going to put a 2. So y is equal to 6. Now all I need to do is write the solution, which is an ordered pair. So my x coordinate is 2, my y coordinate is 6. So the solution to the system is the point 2, 6. Meaning if I actually graph those two equations, then I could see that they would intersect at the point 2, 6. Let's skip to number 4 for right now. Looking at number 4, my first equation is x is equal to negative 2y plus 1. And then the other one is x is equal to y minus 5. Go ahead and label those equations A and B. This looks a lot like the problems that we just worked on just a minute ago. Except for this time, I know that x equals something and x equals something else. So if x equals item 1 and x equals item 2, then item 1 and item 2 are equal. So I can set these two equal to one another. So negative 2y plus 1 is equal to y minus 5. So far, this is a lot easier than yesterday, I think. We'll make it more difficult in a few minutes, though. All right, so get all your variables together. I would add 2y on both sides, so that way I don't have to deal with negatives. So that leaves me with a positive 1. That's a 3y minus 5. Then get all your constants together. So I'm going to add 6 on both sides. I won't write that down. Or I'm sorry, add 5, I meant to say, on both sides. 1 plus 5 gives me 6. So if 6 is equal to 3y, I know that 2 is equal to y, or y is equal to 2. Now that I know what y actually equals, I have enough information to figure out what x equals. So I would suggest I'm going to use the second equation, which is x is equal to y minus 5. So x is equal to 2 minus 5. So x is equal to negative 3. So my ordered pair is, remember, x coordinate first, so negative 3, 2. Okay, let's do one that's more involved, shall we? Let's do number 7. Looking at number 7. And let's label these equations. Put a wall around them. Okay, when you're solving with substitution, you need to take one of the equations and solve it for a variable. But look at your two choices. In equation A has already been solved for y. So you don't have to do that first step. You can just go ahead and substitute this in place of y. So I'm going to rewrite my second equation, equation B. But since I know that y equals x minus 7, I can substitute x minus 7 in place of y right here. So I'm going to bring down the 2x, I'm going to bring the plus sign down, and instead of y though, I'm going to write x minus 7, and I'll put that in parentheses. Equals 8 needs to come down. I put these parentheses around x minus 7 just so you know that instead of writing a y, I wrote x minus 7. But since this is a plus sign, I do not need the parentheses. I can safely drop them. If this had been a minus sign out here, then I would have needed to distribute that negative. So let's combine our like terms. So that's 3x minus 7. And solve for x. So 3x is 15, which tells me x is 5. Now that I know what x is, I need to substitute 5 in place of x for one of these equations. So I would substitute it into the first equation. Just seems like it'd be easier. So I'm going to rewrite that first equation. But instead of x now, I'm going to put a 5. So that tells me y is equal to negative 2. So the solution to this system would be the ordered pair. Remember, x coordinate goes first. 5, negative 2. Be careful that you don't say that the ordered pair is negative 2, 5. Because that would be wrong. Okay, let's do one that's more like what I had you starting off with yesterday. So if you would, let's skip to 16. And we'll label these equations A and B. Okay. So the first step is to solve one of the equations for one of the variables. In the previous problems that we've done so far today, there were equations that were already solved for a variable, so you had less work to do, but that's not the case here. So I need to take either equation A or equation B and solve it for either X or Y. My suggestion to you is if you have a variable that has a coefficient of positive 1, solve for that variable. So if I look, equation B, or the y value has a coefficient of positive 1, and so does the x value. They both have a coefficient of positive 1. So I'm going to take equation B, and I'll solve it for y. So that's y is equal to negative 4 minus x. Remember, I don't have to put this in slope-intercept form. I just need to get y alone. Solve for y. Now that I have solved for a variable, this came from equation B. So this has to be substituted into the equation that I didn't use, in this case equation A. So I'm going to rewrite equation A. But this time, so I rewrote it, but I'm going to rewrite it again, but instead of y this time, I'm going to put negative 4 minus x. So that's 3y, but instead of y, I'm writing negative 4 minus x. And here's where it gets tricky. You need to use your distributive property to get rid of these parentheses. So to begin with, that 5x is not affected. Think of this as negative 3. So negative 3 times negative 4 would be a positive 12, so I'm going to write plus 12. And remember, I'm thinking of that as negative 3. Think of this as negative 3, and that is negative x. Negative times negative is positive, so I'm going to put a plus sign. So that would be positive or plus 3x. Now you can combine your like terms. 5x plus 3x is 8x. Bring down the plus 12 equals negative 4. Now you can solve for x. So I'm going to subtract 12 on both sides. Negative 4 minus 12 should give me negative 16. So x will be negative 2. Now that I know what x equals, now I need to find exactly what y equals. So I can substitute a negative 2 in place of x in either equation A or B. I'm going to go with equation B because it seems easier to substitute into. So instead of an x, I'm going to write a negative 2. So negative 2 plus y equals negative 4. So to solve for y, I would add 2 on both sides. Negative 4 plus 2 is negative 2. So my ordered pair is negative 2, negative 2. I'm going to do one more like that, and then I'll let you have time to practice on your own. Let's look at number 19. So number 19, we have 3x minus y is equal to 4, and 2x plus y is equal to 16. We'll call these equations A and B. Okay, so remember that to solve an equation by substitution, I need to take, and first I need to solve one of the equations for either x or y. I would suggest, just like I said in the previous problem, I would solve, in this case, equation B, I would solve that one for y because it has a coefficient of positive 1. So I'm going to rewrite this equation. And this time I'm going to get y alone. So y would be 16 minus 2x. Now this can be substituted into the equation I didn't use. I used b here, so I need to use this in equation A. Instead of y, I'm going to write 16 minus 2x. So 3x minus, I'm going to put 16 minus 2x in parentheses. Careful here. You cannot just drop the parentheses. You can think of this as distributing the negative sign. So that really changes the sign of everything inside of the parentheses. Comes minus 16 plus 2x. Get your like terms together. 3x plus 2x is 5x. Add 16 on both sides. And then divide by 5. So now x is equal to 4. And now substitute 4 in place of x in either one of the original equations, your choice. We'll just use the second equation. So that'd be 2 times 4 plus y is 16. That's 8. So y is equal to 8. So your ordered pair is, 4, 8. Are there any questions about how to do any